Hello, class. Good morning, good afternoon, and good night whenever you're viewing this. We're going to take a look at the skeletal system, and we are not going to look at the specific bones. We're going to instead look at some of the other functions and uses of the skeletal system and some of the other specific terminology and conditions that it can have. So, first we're going to move on to the functions of the skeletal system. So the skeletal system has a variety of functions. It's not just movement, but it provides body form, so it kind of gives you a rough outline of a human body. Like if you look at a skeleton, it is kind of what a rough human would look like. If you ever heard of skeleton notes, it's kind of a good term for it. Skeleton is just the rough, bare bones parts of human form. They also provide protection. So your cranium or your skull, that provides protection for your brain. Your ribs and like your scapula and your clavicles, they help protect some of your internal organs such as your lungs and your heart. And it also aids in the production of blood solids. So your red blood marrow, they produce a lot of your red blood cells and other things, a lot of your white blood cells as well. And it also aids in motion. So it helps when you walk. Hi, Mr. Sock. So it aids in motion. So like it works together with your muscular system to kind of help produce like things such as walking and moving your fingers and moving your arm and stuff like that. It aids in motion. Also respiration. Put your hands right here on your chest, and then take some deep breaths in and out. You can kind of feel your ribs move in and out, and that's because your skeletal system and your ribs are actually helping you breathe and kind of help contracting and relaxing your lungs to help get air in and out. So those are some of the major functions of the skeletal system. It has a few other small minor ones, and obviously it interacts with all the other body systems, and we will add that in as necessary. Terminology. So I'm going to go over some specific terminology that relates to the skeletal system. So a ligament is tough connective tissue that holds bone to bone in the joint region. So this is a kind of part of a muscle that holds the muscle from bone to bone. So as you can see, here's a bone, that's your patella, and it joins it to your tibia. See, so that's a ligament. And this is in the joint region. So this is your knee, and this would be considered the joint region. Tendon, tough connective tissue that holds muscle to bone in the joint region. So this is a little different from a ligament, as this holds from bone to muscle in the joint region. And you'll have, like in your ankle, you'll have multiple tendons and ligaments that can be sprained or broken. And we'll talk about that later. Also in your joint region is cartilage. This is tough elastic tissue that forms the ear and is found in the joint regions at bone ends. So as you can see, there's cartilage in between your joints. So when some people get arthritis, that means their cartilage is wearing down and they're kind of starting to scrape from bone on bone. Also, like it says, it's in your ear. Cartilage is your nose. That's what it's primarily made out of. All that your ear really is, at least out of bone, is just an opening in your skull. The rest is muscle and cartilage. Sharks, they are made primarily of cartilage. Terminology continued. Marrow is semi-liquid material in the medullary cavity that produces blood cells. So there's two types of marrow. There is yellow marrow and red blood marrow. So red marrow is at the ends of a femur or bone, like it's also in your ribs. So right here you'd have your red bone marrow, and in the middle you'd have your yellow bone marrow. Your yellow bone marrow is more of for storage of fats, whereas your red bone marrow produces more of those blood solids. Periosteum, a membrane that surrounds the outer bone. So as you can see, it's kind of like this outer layer on the bone, outer membrane that surrounds it. And then compact bone, solid bone material that makes up the bulk of the skeleton. So that would be in the middle, like let's say your femur. This is probably like a cow femur, maybe a hog or something like that. And that's more compact, it's not as hollow as spongy bone, which we'll talk about in a little bit. Epithelial line or disc, this is the growth region or growth plate that are located at the ends of the bone. So here you can kind of see in between this red bone marrow, there's this little line right here, and that's your epiphyseal line or disc. And this is how you grow. It kind of grows from this disc. So doctors can look at your disc and see if you're done growing or still have a little bit of time left. Women usually stop growing at about the age of 16, whereas guys can grow all the way up until 25. Joint, location where bone ends meet. So this right here is a joint. This would be your knee joint or a hinge joint. So it's where bone meets bone, as you can see, like that. Bone meets bone. Right here, what I'm showing you, this is a ball and socket joint. So one of the types of joints is your thumb. It's a saddle joint. So it's almost like if you have two saddles that are rubbing up against each other. So if you put your hands together like this, kind of move around, that's kind of roughly what a saddle joint would be like. So it has some flexible motion, but it's not as clear cut as, a regular hinge joint. All right, gliding joint, ankle and wrist. So this is where joints just kind of rub past each other, sometimes at an angle, such as this. They glide against one another. Hinge joint, it's a door hinge. Your elbow is a great example of that. Hinge joint, like a door hinge. Here's a little model of a hinge joint. Ooh, ah. And then you have your ball and socket joint. So you got your ball, which is your femur or your humerus, in with your hip or your socket, shoulder socket. Kind of rolls around. And you get a lot of motion with these types of joints. You can do a lot with your arm, huge range of motion. Pivot, skull rotating on the top of the cervical vertebrae. So it just moves around like that. So when you were in basketball, you know how you're supposed to pivot. You get the ball, and then you move around, and one foot's always on the ground, right? And that's because that's what you're pivoting on. It's kind of like your skull is moving on top of your vertebrae. So like that. It's pivoting around. It's definitely not a vertebrate right here.
Well, can I add one other thing there?
Yep.
Again, Mr. Springer was talking about the shoulder motion being pretty complex, and the hip area also. But that's one thing that separates us from the other primates, that we've got that ability to roll our arm around and throw things, and then we kind of swing them when we walk. And the monkeys, the apes, chimps, things like that, they don't have that ability. And when they walk, their hip is set a little bit different than ours. It's more like this, straight across, so they're kind of bow-legged, where ours is at a little bit of an angle, so they can always tell with skeletons if it's a monkey or a human type. Thank you.
Thanks. All right. Condyloid. This is another type of joint. It's kind of like a bowl or a pestern pestle and mortar type thing. So that's the bowl on the bottom. And then there's kind of an insert here. But this you can get some circular motion like with your fingers, but it's not as full as like a ball and socket joint, but it's very similar. All right, fixed. The bones of the skull. These are non-moving, so as you can see last time, there's a bunch of your skull is made up of multiple bones, but the bones don't move. So when you're a baby, they start to get fused together. When you're straight out of the womb, that's why your baby's head is so soft, so you can't press down on it or put pressure on it. So as you can see here, even on this little animal, it's probably a deer or something like that, you can see the different bones, segments, and how there's different parts of the bone that are fused together. And then these are still joints, but they're just non-moving or fixed. So the skeleton develops with proper diet with calcium and phosphorus. So if you ever heard drinking milk gets you strong bones, that's a thing. You get all that calcium. Proper nutrients, so you got to eat good. You can't just eat candy all day, unfortunately. You got to get them gains. Dang. So exercise and weightlifting. This puts pressure on your bones, which makes them stronger. It's kind of like it's kind of the same idea with muscles. If you keep on breaking them apart, and when you're lifting or running, they're gonna come back together harder and stronger and better like that. And then genetics. A lot of this, almost everything in your body depends on genetics. A lot of variations. So like blue eyes, green eyes, bone. That's something that we've been hitting all year. Conditions of fractured, broken bones. So snap. Broken bones. So there's multiple different types of bone breaks, but we're going to talk about a few. Green stick. Young individual bone is bent and cracked. So as you can see here, there's just a little bit of the bone that is bent and cracked. Not a huge fracture. Simple or contained break. So a simple is straight across and not as at an angle. And that's a compound fracture. So it's a simple break. It's just straight down the middle. So dislocation is a separation of the bone ends from the joint region, several different degrees. So depending on how far it gets out of place, depending how you do it, depending if you get medical attention, that depends on how severe this dislocation is. Another condition is osteoporosis. It's the weakening of the skeletal system. This is due to a lack of calcium or inability to utilize it. So here you can see in healthy bone. And your bone is made out of a lot of spongy material. It's very interconnected. It's not just solid bone, not just solid like a sheet of metal, but it has lots of holes in it. And that's where your red blood bone marrow would be. But in osteoporosis, those holes get a lot larger. There's a lot more airspace, which makes them more brittle. And it's due to a lack of calcium or an inability to utilize that calcium. So your body has the calcium, but it's just not putting it to good use for whatever reason. And it's more common in women. Another fact. Arthritis. And this is inflammation of the joints. So as you can see, these joints are irritated. That would be your knees. Inflamed. Gout is crystallized uric acid in the joint region, and that comes from diet. So your kidneys actually try and get rid of uric acid. That's one of the waste products that it gets, and when your body's not able to excrete it correctly, it's got to put it somewhere, so that's one of the places where it puts it. All right, rheumatoid, inherited situation. So rheumatoid arthritis, this is a type of arthritis that is inherited. And then osteoarthritis. This is wear and tear from constant use. So the cartilage starts to wear down after years of running or just working, and then it just starts to scrape from bone on bone. The cartilage is gone. Alright, rickets. It's curvature of the long bones due to a lack of vitamin D in the diet. So where does vitamin D come from?
Sun.
Sun, yes, the sun.
Works with the skin.
Yep, yeah. So when you get cabin fever from staying in all quarantine, make sure to try and get out in the sun a little bit. Get that vitamin D. So sprain, torn ligaments and tendons in the joint region. And I know this, I constantly roll my ankle. I did it once in high school, and then overall, I just keep on doing it again every so many years and have to be careful about it. And sometimes it kind of hurts when you run too, when I run. Yeah. But overall, yeah, it's just torn ligaments and tendons in the joint region. So as you can see here, they're nice and healthy, not ripped, and here they are. Scoliosis. It's the lateral curvature of the spine. So my fiance has scoliosis. Just the spine. Your spine is naturally curved. Like if you sit up straight, kind of like your belly's out a little bit, and your shoulders are back. That's kind of sitting up straight. And it should be curved to a certain extent. But scoliosis is lateral curvature. It's curvature to the side. And that's not good. No bueno. My fiance, she had a brace for multiple years, try and heal this, and then her grandma, I believe it was inherited, but her grandma, she has severe osteoporosis. She's like 4'9", and she keeps on getting shorter. That's because her spine is just slowly getting more and more bent as time goes on. Progaria. This individual ages prematurely. Bones are brittle. They are short and have a short lifespan. So their age prematurely. I believe this is a single base mutation that results in this. Yep, I think that they live to about 16. Mr. Sock, how long do people with progeria live usually?
Very few make it to age 20.
Very few. Okay.
They tend to, if they have so many physical problems. In fact, I think I just saw a commercial here a while back where an individual had over 200 breaks by the time they're 18.
Wow.
So anytime they get thumped, small bones in the body especially.
Okay. Yep, so rarely make it to age 20. Alright, calcium deposits. Mineral buildup in an affected area of the skin. So these are small calcium deposits in different parts of your skin, and your body is putting that calcium somewhere, or it's trying to fix something, but obviously things have gone bad. Calcium buildups around a fractured area. So your body, there's a fracture, so your bone's breaking and it's putting in calcium, but not all of that calcium is getting used to help heal the break. Some of it's putting in other areas. And bone spur is just a buildup around the affected area, so there's no break with a bone spur. So here, I got something. So what we do now is that we have a lot of phones. So what we do is we sit like this all day playing on our phone. So what this develops is a bone spur right in the back of our occipital in the cranium. So what happens is that this little thing right here starts to get built up and a bone spur develops. And it's uncomfortable. And you're just because you're putting too much unnecessary stress like this. We should be sitting up straight like this all day long. We shouldn't be doing this. So if you're ever using a phone, use it like this. I guess.
Yeah, right.
All right. Gigantism, it's a genetic or pituitary condition in which individuals grow to over 7 foot 6 inches, so very tall. Your pituitary gland is in your skull, right next to your brain. That's an endocrine gland. I think what happened with one person is that they had a tumor in their pituitary gland or very near it, so it constantly kept on producing growth hormone, which then caused your body to grow and grow and grow. Usually you're limited to your height of 7 feet or so, or 6 feet naturally, but different people have developed these genetic or pituitary conditions in which their body just keeps on growing, sometimes until they eventually pass away. Dwarfism, it's also a genetic or pituitary condition in which individuals often fail to reach 4.5 feet in height. So the body isn't producing enough growth hormone, and so they're kind of stunted with growth. And then acromegaly, a pituitary condition in which the individual will continue to produce growth hormone after growing years. So your facial, hand, and foot bones tend to thicken. So depending on the different situation, the growth hormone is maybe activating your hand bones to thicken up, or your foot bones to get thicker, or your chin bone to produce more thickness. And that's it. That's the notes for today. Look forward to the muscular system tomorrow.